Good morning, this is the presentation for the synchronous impedance method and its error. Let's refer to the graph below. Vt is the rated voltage per winding phase, regardless whether its Y or delta connections are used. I is the rated current per phase, and the angle is the PF angle for which the regulation is to be calculated. MF is the MMF of the field, and the voltage which its flux will be generated when MF is acting alone is EO. MA is the MMF of armature reaction, and the voltage it would produce if acting alone is EA. The reducing effect of armature reaction upon the voltage at lagging power factor is shown by adding EO and EA, which would result to EG. Since EA varies with the current and is in phase with reactance drop, regardless of the power factor, it is replaced with new fictitious reactance drop. So the actual leakage reactance of the armature is added a fictitious value, and the sum is called the synchronous reactance, wherein IXS is equal to the reactance drop plus the EA. This is the test data necessary for use of this method. First is the effective resistance of the armature. This will be equal to power input over I squared. Next is the synchronous reactance of the armature. This will be equal to the FEO over FI, or approximately equal to the XS. XS is also equal to the square root of ZS squared minus RE squared. So that's based on the figure shown. It is where the short circuit and the open circuit graphed. From 0 to nearly 20 field amperes is where the unsaturated lies, and beyond that line will be saturated. And another thing to point out is the air gap line, which also causes the confusion or the error. Upon calculating the regulation, ang regulation na ma-obtain natin ay mas mataas sa actual test, which is also called the pessimistic method. And the result, however, is more likely to be on the safe side. It assumes that the synchronous impedance or reactance is constant. And as mentioned before, ZE is equal to XS, but XS is obviously not a constant. So we can simply put that the saturation caused the error in finding the regulation using this method. So let's move on to the example using the synchronous impedance method. Given. Now find the full load current per terminal. I is equal to 164 kVA over square root of 3 multiplied to 2200, which is equal to 43 amperes. Now finding the rated volts to neutral, or the VN. VN is equal to 2200 over square root of 3, which is equal to 1270 volts. Now referring to this graph, which is the one that I've used to show you the saturated and unsaturated, we can find the maximum voltage on the open circuit curve, which is 3200. And at this voltage, the field current is 31 amperes. With the same excitation, produces a short circuit current of 70 amperes. Now let's find the ZS, or the impedance. But first, 3200 over square root of 3 is equal to 1846 volts per phase. Now, dividing that to short circuit current, we will have 26.37 as an impedance, or the ZS. And as mentioned a while ago, ZS is approximately equal to XS. Now, finding the EO is equal to VT plus IRE plus JIXS. By substitution and simplifying, we will arrive to 1721 volts. Now finding the regulation will be EO minus VT over VT multiplied to 100. We will arrive to 35.5% at unity PF.